This is a guide to the upper control board for the FBD 560 series of units. This covers the tools and materials required, reviewing the board components, basic troubleshooting, and how to replace an upper control board. These are the basic tools and materials you'll require to troubleshoot and replace an upper control board. The materials table shows the FBD components for the upper control board with the Lancer part numbers. The upper control board is located behind the merchandiser and keypad. Removal of 2 Phillips head screws is required to access this section. We will review the basic layout of the upper control board looking at components, connections and indicator lights, and will also compare the older revision to the new model released in November 2015. The relay board is common to both FBD 562 and 563 units. It is mounted to the upper control board by plugs and sockets on the reverse side of the relay board. Please note the location of the FBD part number. This is the reference for setting up a new revision of the upper control board. The merchandiser door annunciator panel signal cable is connected to the socket on the top right hand side of the relay board. It is important to note that the relay coils operate on 5 volt DC and that these are typically switching 24 volts AC. The contrast of the LCD display can be adjusted. A small screwdriver is required to make this fine adjustment. Turning anti-clockwise will darken and clockwise will lighten the contrast. The blue pot's location and function is common throughout the 560 series of units. The EEPROM is a pre-programmed chip that holds the program or software to manage the FBD unit. The EEPROM has factory-loaded defaults or settings that will enable a consistently good product without any modification by a technician. Any changes or tweaks made to this program via the service menu will not overwrite the EEPROM software. These changes are held by onboard memory chips. As of November 2015, new FBD units, both the 562 and 563, have a B variant EEPROM in line with the new upper control board released at the same time. Integrated circuit microchips process the information received from the unit's components, such as the lower power board, pressure and temperature sensors. The memory timer module keeps the unit's time, stores the local program changes and records data. Both the microchip and timer modules are supplied with the board and will require limited attention. The keypad ribbon cable connects to the upper control board just above the Actel chip. This cable is part of the keypad membrane glued to the hinge door. The membrane can be peeled off if damaged. The LCD displayed for the 563 here is mounted to the hinge door and is connected to the upper control board via the grey ribbon cable. The 563 has a longer 40-character LCD display. For the cable connections to the upper control board, we'll start by reviewing the inputs, pressure and temperature sensors. Firstly, with the common inputs, which are the pressure transducers for the supply or unregulated CO2, the internally regulated CO2, and then water or H2O pressure. Then to each barrel, which has syrup and tank pressure sensors. The connections are all well labelled. Then on to the temperature sensor harness sockets, which are the last on the right hand side of the board. Again, these are clearly labelled, remembering each harness has an inlet and return temperature sensor attached to it. Now we will review the harness connections for supplies, controls and outputs, which are located to the left hand side of the board. Starting with P5, the main control cable between the upper and lower boards, the machine's voltage, beta motor power, compressor contactor and condenser fan switching and signalling pass through this cable. P6 is the 24 volt AC supply point to the upper control board and relay module. This voltage is switched via the relays for the solenoids, contactor and LEDs. There are no test locations or indicator lights for the 24 volt AC on the upper control board. If required, use the plug in the socket P6 to test 24 volt AC at this location. These are the output control harnesses. P7 supplies the product, solution and gas solenoids. P8 supplies the refrigeration, pulse and hot gas solenoids. P12 is the DC supply cable from the lower control board. It supplies 5 volts and positive and negative 15 volts DC to the upper control board. There are LEDs and test points to confirm and assist with troubleshooting of these voltages on the upper control board. The pinout of the female plug for P12 is for reference. This may also be required during troubleshooting. Having reviewed the 3-barrel unit components, we can now look at the different components the FBD 562, a 2-barrel, has. The upper control board and relay board are the same. The 562 though requires a 510 version EEPROM. On the 562, the keypad layout is different, as it only requires controls for 2 barrels and a smaller display. The 20-character display is directly plugged into the upper control board. If you are replacing an upper control board for a 562, then keep the white display supporting posts and fixings that attach the right-hand side of the display to the board. It is important to note that for FBD 562 that the pressure and temperature sensors and their harnesses are still the same, except that the right-hand side barrel, or side 2, is connected to the center socket on the upper control board. This is a summary page to pause and review the connections and components of a typical FBD 560 series upper control board. This is the latest revision board, so please note the relay board selector switch and the relay board part number required to set this position. The technical bulletin shown here is available for review and covers the major changes to the upper control board, such as the test points and LED voltage indicators, EEPROM revision, the relay board selector switch. It also includes a parts clarification matrix. Due to the release of the new upper control board in November 2015, we'll need to review 2 different versions of the upper control board. They are functionally the same, but have key differences that can cause some confusion, particularly with the position of the test points and LEDs and the relay board selector switch. This layout of the upper control board has been around since the beginning. It is identifiable by 3 LEDs that indicate the voltage status next to the blue contrast pot. LEDs indicate a healthy DC supply voltage. From left to right, the LEDs are negative 15 volts, positive 15 volts, and positive 5 volt DC. 15 volts DC is used to provide voltage to pressure and temperature sensors. 5 volts DC is used to supply the relay board coils and the logic processors. The next key indicator of a healthy upper board is the flashing LED on the far right hand side. This is the heartbeat LED indicator. This means that the processor and the program are functioning correctly. Each of the test points are clearly labelled on the board. Ensure your multimeter has DC selected, if not in an auto ranging position. Then make sure you have a good contact with your probes, and specifically that you're using the ground on the upper control board, i.e. test point 8. The 24 volt AC supply to the upper control board does not have a test point or an LED indicator. If voltage confirmation is required, use the plug connected at P6, remembering to set your multimeter back to the AC range. This is a video of the board in a normal operating state. Note the 3 green LED lights and the 1 flashing heartbeat light. This new revision of the upper control board has some subtle layout differences. The connections and operating principles remain the same, but what you'll notice is the modern hardware and smaller components. The voltage indicator lights and test points have been moved, and there is a relay board selector switch now added, but the board still remains very clearly labelled. The voltage supplies and their usage is exactly the same as the previous revision. 5 volts DC is used to supply the coils on the relay board and the logic processor. 15 volts DC is to control the sensors. And 24 volts AC is switched by the relay board to energise the LEDs, the contactor and the solenoids. The important test points have voltage indicating LEDs. There are now 6 LEDs to assist with voltage confirmation, and there is still 1 heartbeat LED indicating that the processor or software is functioning correctly. Each of the test points are labelled and are much easier to access. The key when testing is to ensure that you have DC voltage selected on your multimeter and have a good connection with the probes, and that you're using the ground on the upper control board, in this case such as TP7 or TP8. 24 volt AC supply to the upper board still does not have a test point or an indicator. If required, use the plug connected to P6, remembering to set your multimeter into the AC range. With respect to the relay board selector, there is now also 1 LED indicating the current selection. When you install the relay board to the new upper board, check the FBD part number on the relay board and adjust the dip switch to suit as per the instruction screen printed onto the board. The relays will not operate if set in the incorrect position. Having reviewed the onboard hardware and the connectivity to peripheral hardware, we need to also look at software. It's very easy to replace components before spending time looking at software diagnosis. The four most common areas that we'll review that can cause an issue with an upper control board are the power supplies, the relay board and harness, the display, and then the software. The key here is to making sure to understand the fault first before replacing parts. Start by checking that the unit is set up correctly, the critical settings, reviewing supply voltages, pressures, flow rates, and then make sure the program's running okay. All the power supplied to the upper control board originates from the lower power board. The voltage indicating LEDs on the upper control board should be all on during normal operation, and the heartbeat LED should be blinking when all the chips are seated correctly and the 5V DC is present and the processor is functioning correctly. Review the supply indicating LEDs to diagnose any supply issues. If any LED is absent or dim, first check with the lower power board, voltage indicating LEDs and supply transformer fuses. Inspect the DC supply wiring harnesses, plugs and sockets, and then use a multimeter to confirm actual voltage at the upper control board. When testing, ensure a good connection to the board with the probes and between the required test point and board ground. The voltage measured should typically be within 5% of the labelled value. If the heartbeat LED for the IC chip is off, first check that the 5V DC is available at the upper control board. If so, then cycle the power to the unit, leaving it off for at least 30 seconds, and then reloading the EEPROM may be required to reset and refresh the program. If the relay board is not switching or individual items are not activating, first of all, check the 5V DC supply to the upper control board. Check that the 24V AC is supplied from the lower power board, and ensure that the relay board is seated or plugged in correctly. Remove and inspect the board. Inspect for broken or bent pins, burn marks on tracks or relays. It is very important that if we see these burn marks, that we inspect all solenoids and coils prior to re-energizing the new board, as this fault will reoccur again if it's due to a failed solenoid or coil. Cable and harness faults, depending on where it occurs, will show us floating values from sensors, short circuits, blowing fuses, fast cycling values, low voltage errors, and buttons not working. These are typically due to nicks or wear in the insulation or kinked ribbon cables, damaged plugs which have bad joints or poor crimping, or the cables and plugs are loose and has bent or broken pins, or incorrectly connected, loose or misaligned. This is typical with displays and keyboards, and incorrect sockets for pressure sensors and temperature sensors, particularly in the FBD 56X range. These are the three most common LCD display faults. Faint text or lack of contrast is simply reviewing the contrast adjustment pot until the text is well defined as per the video. A blank screen with no backlight but has a green hue, check and adjust the contrast, and if this has no effect, unplug and inspect the cables and plugs and sockets. If all okay, then replace the LCD. If it's a blank screen with no backlight, then no power is available to the display. Check that all the voltages are supplied to the upper control board, unplug and inspect the cables, plugs and sockets. If all okay, then replace the display. But before you do any of this, it's good to check the display on another FBD unit, because the FBD will work without a display. Software and displays. When the display shows Chinese characters that are undecipherable or fast flickering text or general gibberish, this is typically due to a program not loading correctly, or the EEPROM or the memory has become scrambled or unstable. This fault typically occurs after voltage dips or power failures, or where the EEPROM has a problem that requires replacement. Start by pressing the cancel button a few times to see if the text will clear. If it does not clear by pressing the cancel button, then try holding down the cancel and grey button together for 5 seconds. Then try cycling the power to the unit for at least 30 seconds. And if this does not work, then try removing and then replacing the EEPROM, which forces the program to reload. EEPROMs can be damaged by voltage spikes, handling, static discharges, or by not being seated correctly. When badly damaged, missing legs, or installed upside down or not seated correctly, the unit will either appear dead or be making lots of noise, as it will be operating randomly. EEPROMs can have corrupted software or bugs. These will require a replacement. Typically they will be unable to wake from a program sleep cycle, missing menu systems or menus will appear in the wrong place, or fast cycling beta percentages. Beta percentage issues. Fixed or odd values fast cycling, please start by checking if the gearbox and motor is physically okay, an electrical and mechanical inspection. Check the bricks of the product in the barrel and the condition of the scraper blades. Ensure the lower power board and its associated equipment and cables are okay. Ensure the critical voltage offset has been reviewed, and then look to cycle the power to the upper control board, reload the EEPROM by loading all defaults, and, or last of all, installing a new EEPROM. After reviewing supplies, the motor, the capacitor, cables, software, and if the fault is not product related, then replacement of the lower power board may still be required. Before removing the upper control board, disconnect and isolate the FBD from the electrical supply. When removing the upper control board, start with the EEPROM using an EEPROM chip removing tool. Take care to pull directly back and not to bend the legs on the chip. Disconnect the display ribbon cable, then remove the annunciator signal cable, then remove the keypad ribbon cable, taking care to only pull on the plug. Remove the relay board to get to the fixings behind it. Then remove the 6 fixings, keeping the screws and the plastic washers that encapsulate the screws for reuse. Lift out the old board and fold it down, the cables will hold it, and then install the new upper control board reusing the screws and washers from the previous board. We need to reconnect the harness for the power, control and sensors. Please take care to ensure that they're connected into the correct location and that the plugs are securely latched back into place. Replace the relay board, taking care to align it correctly as not to damage any pins in the sockets, and ensure it is firmly seated into the upper control board. Replace the annunciator signal cable, tuck it in behind the board, and then secure the plug into socket J1 on the relay board. Carefully realign the keypad ribbon cable plug into the comb style socket. Take care connecting the display ribbon cable as not to damage the socket's pins. Reinstall the EEPROM with the notch up and ensure all the legs are aligned with the corresponding holes before gently pushing the EEPROM in. With the upper control board install completed, test and tag the FBD and then reconnect the electrical supply. All looks to be okay, but to confirm that the EEPROM has loaded correctly, scroll through to the service menu, which is accessed then by the grey button. At this level in the program menu, scroll through to load all defaults and press select. Press select again to confirm. Now we have pulled the program from the EEPROM into the memory. Then press cancel 4 times to get back to the default program position.